Good. In question 1, the formula for methane is CH4, where the formula for ethane is C2H6, which will describe diffusion and relative rate of diffusion of methane and ethane. So rate of diffusion depends on two factors. One is the molecular mass, relative molecular mass, and the second one is the temperature. So when we find the relative molecular mass here, carbon is 12 plus hydrogen is 1 multiplied by 4, so that is 16. For ethane, it is 2 multiplied by 12 plus hydrogen is 1 multiplied by 6. So 24 plus 6, that's make 30. Because methane is lighter than ethane, that's why the methane will diffuse faster. So which one is a description of a diffusion? Diffusion is actually a movement of a molecule from a region of a high concentration to a region of low concentration. So particle movement from high concentration to low. So the first column, this can be right. Then relative rate of diffusion, when we compare the relative rate of diffusion here, ethane diffuses more quickly than methane. That is not correct. Why it is not correct? Because ethane is heavy, it cannot diffuse faster. So the second statement is not correct, the first one. The particle move from high concentration to low, that is true. And the methane diffuses more quickly than ethane because ethane is heavy where methane is lighter. So CH4 relative molecular mass is 16, where for ethane it is 30. That's why methane diffuses faster than ethane. Which test is used to show the sample of a water is pure? That the sample of water. So to check the pure water, what we do? To check the purity, we can use techniques such as check the melting point, boiling point, or use chromatography. Because if it's a pure water, it will boil at 100. So evaporate the water, that does not give an idea that whether it is pure or impure. Evaporate the water to see if any solid remain, but that is not the test to check the purity. The purity can only be checked by using the melting point, boiling point, or chromatography. So heat the water and check the boiling point, that's true. So B is the right answer. Option C, test with anhydrous cobalt chloride, cobalt to chloride. This will give indication that there is water present, but this does not show the purity. Just you identify that there is a water present. And using a universal indicator, checking the pH just gives an idea that the nature of a water, whether it is acidic, alkaline, or neutral. But again, it does not give any impurities are present or not. Chromatography is used to separate and identify components, both colored and colorless mixtures. For colorless mixture, chromatogram has to be treated with another chemical. So what we use a locating agent. We spray the chromatogram with locating agent, which will make the spots visible. So we can easily measure the RF value or identify the number of components present in the substance. Lithium reacts with fluorine to form a compound called lithium fluoride. So lithium belongs to group 1. So in the valence shell, the last shell, it is having 1 electron. Where chlorine belongs to group 7, so it is having 7 electrons. During a reaction, lithium lose electron and chlorine gain. So lithium will form a positive ion, where chloride ion is formed, which will be -1. So each lithium is losing 1 electron and the chlorine gains 1 electron. So fluorine atoms gain 1 electron, that is 2. So for question 4 is the right answer. In question 5, carbon 14 and 6 and 12 and 6 are isotopes. So what are they have the same number of protons but different number of neutrons. And because isotopes have the same number of electrons in the outermost shell, so they will have the same chemical properties, similar chemical properties. So the carbon 12 is more reactive, that is wrong. Carbon 12 is more reactive, that is totally wrong because the reactivity is same. So the reaction of carbon 12 are similar to carbon 14 because they have the same number of electrons in the last shell or outer shell. The molecular structure of hydrogen N2H4 is shown. Which description about the bonding is not correct? So nitrogen belongs to group 5. It will share 3 electrons. So one side is shared with hydrogen hydrogen and the other one is shared with another nitrogen. So this is a molecular structure of N2H4. So when we check, each nitrogen has a non-bonding pair of electrons. That is true because nitrogen belongs to group 5. So when it belongs to group 5, it shares 3 and unshared non-bonding electrons are there. That's true. Each nitrogen atom has 4 bond pairs of electrons. That is wrong because how many bond pairs are there? 1, 2, and 3. And from the structure, you can identify this is one bond pair, this is a second bond pair, and this is a third bond pair. So 3 bond pairs are there, not 2, not 4. That's why statement B is incorrect. And each nitrogen share one of its electron with a nitrogen atom. That's also true. And each nitrogen atom shares 2 electrons with a hydrogen. That's also true. In question 7, solid X has a high boiling point. Its structure has a positive ion and is surrounded by sea of electrons. So this gives an idea that it is a structure of a metal. So which other property? Brittle. Metals are not brittle. Metals are hard. So this is wrong. Metal cannot be insulated. The metals are malleable and they are good conductor of heat and electricity. So C is the right answer. Why not D? Malleable is correct, but insulator is not. The formula of some ions are shown. In which row the formula is not correct? So how we can, for aluminium oxide, so aluminium belongs to group 3, valency is +3 and oxygen is -2. So we simplify and cross multiply. It should be Al2O3. That's correct. Iron 2 nitride. So iron 2 means Fe is +2 and nitrogen belongs to group 5, so it is -3. So when we cross multiply, it will be Fe3 and N2. But here it is written opposite, Fe2N3 is written, that's why B is not the correct formula. Sodium sulfate and zinc nitrate, when we work out the formula, it will come out correct. The equation for decomposition of a magnesium nitrate is shown. Which volume of a gas is produced when 0.1 mole of a magnesium nitrate is decomposed completely? So first we have, because they're asking the total volume of a gas, so we have to find what is the ratio between the reactant and the gas. So how many moles of reactant magnesium nitrate 2? How many moles of gas are present? This is solid, so nitrogen dioxide is a gas and oxygen is a gas. So 4 + 1, 5 moles. So the ratio between the reactant, the moles of the reactant and the moles of the gas, 2:5. So if we have 0.1 moles of magnesium nitrate, X moles of a gas will be there, we cross multiply. So it will be 2x is equals to 0.5 multiplied by, means 5 into 0.1, it will be 0.5. Or we can 0.5 into 0.1 into 5 divided by 2. So when we simplify this, it will give us 0.25. So 0.25 moles are there of gas. But in the question, we need the volume. So volume of a gas is equals to moles divided. Because we have moles equal volume divided by 24. Volume of a gas in decimeter cube divided by 24. So moles are 0.25. Volume is 24 and volume of in dm cube. So 24 is divided, other side will be multiplied. So it will give us 6 decimeter cube. So C will be the right answer. Question 10, which statement about electrolysis of the molten lead to bromide is correct? Are correct. So we are doing electrolysis for a lead to bromide. There is a lead ion and there is a bromide ion. And we pass electricity through it. Then towards the anode, bromide ion is attracted, and when one bromide ion will move there, it will lose 1 electron, change to bromine atom. When 2 bromide ions, they will lose 2 electron and form a bromine gas. Because it is a loss of electrons, so this changes oxidation. And lead ion is attracted towards the cathode, it will gain electron, and it will turn into lead atom. So because it gain electrons, we call that as reduction. So we will check which statements are correct. For question 10, lead ions move towards anode Lead ions are not moving towards anode, it is moving towards cathode. Lead ion move towards cathode, that's true, and are reduced, that is also correct. Bromide ion move towards anode, correct, and are oxidized. So even when you're solving, when the first statement 2 is correct, so you can check, identify where the option which is not having 2 is not correct. Then bromide ions are moving towards the anode and they're oxidized. Oxidation is a loss, so that is also true. So 2 and 3 are the right. So 4 is not correct because bromide ions are not moving towards cathode. In question 11, aqueous copper 2 sulfate is electrolyzed using inert electrodes, the carbon electrodes. So it contains copper ion, it contains sulfate ion, and it contains hydrogen ion and hydroxide ion. Copper is less reactive, so will move towards the cathode. When copper ions are there, they will take 2 electrons, turn into copper atom. And hydroxide ion, when 4 hydroxide ions will move there, it will release oxygen into water molecules. And -4 is also there. So which statement is correct? Bubbles of hydrogen. There is no hydrogen gas is not moving. That's why we don't observe. Bubbles of oxygen are formed at cathode. Not at cathode. It should be at anode. But oxygen gas is there, but not at cathode. It is at anode. Copper is deposited at anode. That is also wrong because copper is deposited at cathode because copper is moving towards the cathode. And blue color of a solution fade. That is true because the concentration of a copper ion in the solution decrease. That's why this blue color will fade. In question 12, this is about enthalpy change or energy change using a bond energies. So nitrogen trifluoride is used in manufacture of certain types of solar panels. The equation is there. So first, whenever you have a question related to bond energy, show the bonds. So N2 means nitrogen, nitrogen triple bond. F2 means fluorine, fluorine single bond. And how many of them are there? 3 of them. And as a result, it produced NF3, nitrogen trifluoride. How many molecules are there? It produced 2 molecules of nitrogen trifluoride. So bond reactant side is a bond breaking side and the product side is a bond forming. So bond which we are breaking, so nitrogen, nitrogen triple bond, we are breaking plus fluorine, fluorine, and how many of them? 3 of them. And bond forming, nitrogen trifluoride, so NF, and how many? 1, 2, 3, 4, 5, and 6. So 6 bonds are forming. So we substitute the values 950, and this one is 3 into 150. This one is 6 times 280. So when we solve, so 950, this 3 into 150, that will be 450 plus 950, that will give us 1400 kilojoule per mole. And 6 multiplied by 280, that will give us 1680. When we calculate the enthalpy change, energy change, that is the bond breaking minus bond forming. So bond breaking energy is 1400 minus bond forming 1680. So that will give us the negative answer. So B will be minus 280. So B will be the right answer for this question. Which statement about hydrogen fuel cell are correct? Reaction between hydrogen and oxygen is endothermic. That is not correct because the reaction is highly exothermic. The waste product is the waste product in hydrogen fuel cell is water. That's true because hydrogen combined with oxygen gives water. A chemical reaction in the cell produces hydrogen, which is used as a fuel. So chemical cell is in this basically chemical reaction cell does not produce hydrogen here. So that is, this statement is not correct. And a hydrogen fuel cell is used to generate electricity. That's also true. So statement 2 and statement 4 are Correct. In question 14, which change is a physical change? Physical change, there is no new substance from, that's called a physical. So copper to carbonate uh, changes from green to black, it means it decomposes. So copper carbonate on heating gives copper oxide plus carbon dioxide. Copper oxide is black, so this is not a physical, it's a chemical. Ethanol react with oxygen, so new product is formed, so chemical. Hydrogen peroxide decompose or chemically change. Ice form liquid water when it is heated, so there is no new substance formed. That's why D is a physical change. A student adds excess of magnesium ribbon to 10 cm cube of 0.5 mole per dm cube sulfuric acid. A gas is collected and a volume is measured every 10 seconds. Experiment was repeated using a same mass of a magnesium, but smaller, same concentration of acid, but small quantity. So if we reduce the amount of a limiting reagent, because sulfuric acid here is a limiting reagent, so amount of the product will also decrease. So if the original reaction is this one, we have to predict which graph shows the result of the second experiment. So second experiment should be slower first thing, and amount of a product should also be less, because we reduce the amount of reactant, the limiting reagent. So that's why D is the right answer. But if there was the same question and they said that magnesium is still in excess and we reduce the amount of magnesium, then the amount of a product will be same, but the rate of the reaction will be slower. For a reversible reaction, the forward reaction is endothermic. So endothermic reaction means the reactant is having less energy and the product is having more energy. So what is the effect of changing a temperature? Increasing a temperature shift the equilibrium towards the right, because the forward reaction is endothermic. And what about pressure? We have 1 mole. So increase in pressure shift the equilibrium towards side where number of moles are less. So increasing a temperature will shift the equilibrium towards right, where increasing a pressure will shift towards left. So C is the right answer. In question 17, in which reaction is the underlying substance as a reducing agent? So a substance which is acting as a reducing agent itself, it is oxidized, and oxidation is a loss of electron, or in terms of oxygen, addition of oxygen is known as oxidation. So reducing agent itself, it is oxidized. And in terms of oxygen, oxidation or oxidized means addition of oxygen. So here we have carbon dioxide turned to carbon monoxide. This is a loss of oxygen, first 2 oxygen, then 1. When we check this one about the underlying carbon, first no oxygen, then it becomes carbon dioxide. So when we compare the change, it is an addition of oxygen. If there is an addition of oxygen, what we call that change as oxidation, or a substance is acting like a reducing agent. So B will be the right answer. When we check the third one, underlying substance, here iron 3 oxide is there, become iron. So it is a loss of oxygen. So if loss of oxygen, it means it is a reduction, or it is acting like like an oxidizing agent. And HCl is there. There is no, for hydrogen, in terms of oxygen, again you can see there is no, even though this HCl, it has oxygen is added, but why this is not oxidation? Because there is no change in oxidation number. Like when you write oxidation number, the charge appear on the element when it form a compound. So here each oxygen is -2, each hydrogen is +1. So 2 hydrogen will be +2. So before the reaction, hydrogen is +1, and after the reaction is also +1. So there is no change in oxidation number. That's why it is not even a redox reaction. In question 18, this is about the nature of the oxide. So it is water soluble, ability to neutralize, means oxide X can react with an alkali. If it can react with an alkali only, so it is acidic oxide, because acidic oxide can react with base. Oxide Y can react with both acid and alkali, so it means it is amphoteric. And oxide Z is only reacting with acid, so acid means it is alkaline or alkaline or basic. So A is the right answer. Acidic oxide can react with base, basic oxide can react with acid, and amphoteric can react with both, and neutral oxide cannot react with acid nor with alkali. 4 different acids are there. Which beaker contain the most concentrated? So the one which contains the greater number of hydrogen ion, that is the most concentrated, because acids are proton donors. So 1, 2, 3, 4, 5, and 6 hydrogen ions. Here only 2 hydrogen ions. 1, 2, and 3 hydrogen ion, and 1, 2, 3, and 4 hydrogen. So the one which contains greater number of hydrogen ion in the unit volume, that is having the highest concentration. So 19A is the right answer. In question 20, the following substance can be reacted together to prepare salt. In which reaction can the excess reactant be separated from a solution by filtration? So when we check copper 2 oxide react with excess of high, if we use excess of acid, all the metal will or metal oxide metal will dissolve, so we cannot remove, so this one cannot be used. Hydrochloric acid and excess of sodium hydroxide, even though sodium hydroxide is in excess, but that is aqueous substances. So even though we add more sodium hydroxide, but unreacted sodium hydroxide will be in aqueous. So aqueous substances cannot be, or excess of aqueous substance cannot be removed by filtration. So hydrochloric acid and excess of zinc carbonate, so the unreacted zinc carbonate will left there, we can separate by filtration. So D is the right answer. So this was Feb March 2020 paper 2 variant 2. Next session I'll discuss the remaining question from 21 to 40.